Okay, so in this part of coord job, basically you already learned all the required technique and the formula already. So the purpose of this teaching worksheet is to expose you, is to mix in all the technique and then also to expose you to all the different shapes. Okay, so I will start by going through all the shapes property. So for example here, I will show you the properties of parallelogram. Okay, I will not be going through the basic one. The basic one, like opposite length are the same, and that opposite are parallel. So I assume you will know that the opposite are parallel and the opposite are actually same length. Okay, so I'm scraping this basic idea of, so I will not be emphasizing this, but take note of same gradient. Same gradient means, right, the gradient that you calculated for AB is the same as the gradient you calculated for DC. Okay, so sometimes you might need it for finding equation. Okay, the focus is more on the diagonal. So in a parallelogram, we are still able to use the midpoint of a diagonal. Midpoint of AC is equal to the midpoint of BD. Okay, so you got to make sure that the alphabets are in running order. So either clockwise or anti-clockwise. Okay, so sometimes some students, they didn't arrange the alphabet correctly, then they got the wrong midpoint. Okay, so this is one of the things that you will need to understand. If you need to use this when you're finding the fourth coordinate. So this one, we already mentioned it in the previous teaching worksheet. So I'm going to re-emphasize it in this property of parallelogram. Then in the next one, we got the next property. The next property is a rhombus. Okay, so the rhombus is also the same idea. So the rhombus, all the lengths are the same. So all of you will know that all the lengths are the same, and the opposite are parallel. Okay, so you still need to remember the basic one. But in this case, right, again, it's on the diagonal. They share the same midpoint. So the midpoint of the diagonal are the same. So the midpoint of AC is equal to the midpoint of BD. So if this one is useful when you need to again find the fourth coordinate. But what is more important is the diagonal cuts at 90 degrees. So you are expected to know that the diagonal of a rhombus cut at 90. For parallelogram, it doesn't cut at 90. You are expected to know. So when a question comes out for rhombus, there are some students who didn't know that the diagonal actually meet at 90 and they couldn't do certain things. So why is the diagonal cutting at 90 important? Because if the diagonal is cutting at 90, it means that the diagonal are perpendicular. It also means that the product of the gradient will be equal to -1. So that is very important for rhombus. So that's one of the things that you need to remember. The question expect you to know. They can just draw it, but they will not tell you that it's a 90 degree. So it's part of what you are expected to know. So that's why this one is important. Okay. And then in the next one, that will be a rectangle. So again, for rectangle, we do know the basic the basic property that the opposite are same length and also the opposite are parallel to each other. So these are the same thing. So the one that I want to emphasize will be the diagonal. So again, we got the diagonal thing. So the midpoint of AC will be equal to the midpoint of BD. So it's the diagonal. So that one is useful for the fourth coordinate. Okay, the diagonal in this case is like parallelogram. It's not 90 degrees. So it's just the diagonal. we won't know what is the angle. But the one thing about rectangle is there's a lot of 90 degree. So there's a lot of 90 degree, meaning, right, you can use a lot of the perpendicular gradient formula. So for example here, AD is, I'm just showing you one of them. So AB is perpendicular to AD. So the product of the gradient will be equal to -1. So you got 490 degrees for you to play around. Okay, so you can write it out yourself. So the awareness is the 90 degree that comes from the property. So with this perpendicular, you can apply the gradient of the perpendicular line formula. So again, this is something a lot of students, they may not remember, or they may not apply even if they see a 90 degree. So that is a rectangle. Okay, for a kite, so a kite, you can see a kite as two isosceles triangle. So it's something like this. So a small isosceles triangle and then a bigger isosceles triangle. So I always see a kite as making up of two isosceles triangle. So in this case, right, I cannot apply the diagonal idea. Okay, because it's not like the typical shape. So if this is a kite, I only know that to me it's like two isosceles triangle. Okay, and I cannot so don't misinterpret. You cannot interpret that the midpoint of AC is equal to the midpoint of BD. Common sense will tell you that it is not. Can you see? They don't share the same midpoint. Okay, so those midpoint of the diagonal that's applicable for rhombus, parallelogram, rectangle, all these, right, is not applicable here. So the only thing that's applicable is E is only the midpoint of E is the midpoint of BD. Other than that, it's not. So E is not going to be the midpoint of AC. Okay, so I hope you can see the shape doesn't match the idea. Okay, so there's only one midpoint, but there is another 90 degree here. So the diagonal of the kite also cuts at 90 degree like a rhombus. So that is an expected of you. So the diagonal are perpendicular. They may not share the same midpoint, but they are perpendicular. And you are expected to know, and then you can apply the perpendicular gradient formula. So later on, if you try this question, say there is a 90 degree that you are expected to know. Okay, so other shapes could be trapezium. So trapezium got not much things. So the characteristic of a trapezium is just a pair of parallel lines. So we don't have a lot of characteristic. So it's just one pair of parallel line. So AB is parallel to DC. So the gradient are supposed to be the same. So not much property, except that later on, if you're trying this question, they gave you a 90 degree. So if they give you the 90 degree, again, you must apply the perpendicular gradient formula. But it's not every trapezium that you got 90 degree. So the question here has 90 degree in the trapezium. But generally, any general trapezium is just a pair of parallel lines. Okay, so your job is to try all the shapes question that comes with it. Marry whatever technique that you learn, like simultaneous, shoelace, and midpoint, all in this teaching worksheet.